talked about how to simplify these things. Now, let's talk about adding them together, subtracting them by each other, ones that we can add together and subtract by each other, and ones that we can't. Okay? So remember back in grade 9, we talked about like terms. So if I said, what's 4x plus 3x? 7x. Okay. What's 4x plus 3y? Really? What? Say that again? 4x, 3y. You just took out the plus sign? 7xy? Anybody else got an answer to 4x plus 3y?
4x.
Well, you were talking. Weren't you given an answer? Oh, all right. All right, sorry. So 4x, 3y, 7xy.
4x.
What's that?
X plus.
Yeah. Are they like terms? No, so you can't add them together. So you can't do anything with that. Right? How about 6x squared plus x squared? 7x squared. 6x squared plus x cubed. Can't add them. They have to be identical. They have to have identical variables and exponents to add them. So like radicals are the same kind of thing. Okay? They have the same, and the plural of index is indices. And remember, the index is the root that we take, square root, cube root, fourth root. Okay? And same radicands, the same expressions or numbers underneath. So if they're different numbers, if they're both square roots but they're different numbers, we can't combine them. Okay? If they have the same numbers underneath or the same variables underneath, that we'll see one example. So for example, this, or sorry, no, I'm going to go on to this first. So if I said this, 2 root 3 and root 3, would you say those are like or not like?
Not like.
Do they have the same indices? Are they both the same type of roots? They're both square roots. Do they have identical numbers under the square root sign? They are like. Doesn't matter if there's something in front. That's not what we look at. Six root 11 and 5 root 8. Both square roots, but they don't have identical numbers underneath, not like. Cube root 7 and square root 7. Not like, because they're not the same indices. This is square, this is cube. Okay. So this first example here, when we're adding these two together, are they like? Yes. So just think of it this way. You've got 2 root 7s. Imagine what a root 7 would look like. I don't know. A circle, a ball, a square, something. You got 2 of them. And you add 13 of them. How much do you have in total? 15 root 7s. So all you do to combine like radicals is you combine the number in front and then make it root 7. pretty straightforward. Like or unlike? Unlike. But could I do something to one of them? Could I simplify this one? This is the same as root 6 minus, how would I break this down? Highest perfect square that goes into 54. Tell me the highest perfect square number first. 9, which means this is 6. Good. Gives me root 6 minus 3 root 6. After simplifying, they turned into like radicals. And remember, root 6 is the same as 1 root 6. So think 1 root 6 minus 3 root 6. Negative 2 root 6. You guys will probably reach the point where you'll stop showing this step. It's not necessary to show this step. Some of you may be able to go directly to this now, and that's fine. If you're still not completely comfortable with that, that is absolutely fine too. Okay, this one, oh boy. Well, they're not like, but it looks like I can do a whole bunch of simplifying just by looking at those numbers under the square roots. So here's how we'll break it up. 2 times, and now let's break this up. Highest perfect square. 4, which means this is 3. Plus, I can break up root 50. Highest perfect square. 25, which means this is 2 minus 2 highest perfect square. 25 again, and this is 3. This last one you got to watch out for, because there's more than one perfect square that goes into it. Make sure you pick the highest. 16. 4 does go into it, but it's not the highest. 16 is the highest, which means this must be 2. So that gives us 2 times 2 root 3 plus 3 times 5 root 2 minus 2 times 5 root 3 minus 6 times 4 root 2. Well, can't I multiply these numbers together that aren't under the square root? What's the simpler way to say 2 times root 3? Root 3. Plus 15 root 2 minus 10 root 3 minus 24 root 2. So after all that simplifying, I did get some like terms. I got 2 pairs. I got a pair that have root 3s in them, and I got a pair that have root 2s in them. What do I get when I combine the root 3s? Negative 6 root 3. And when I combine the root 2s? Negative 9 root 2. Okay. Looks like a lot of work, but you guys will get these will start coming back to you even quicker. Okay. Remember, this is only the second day we're reviewing these things, and it's not like you review them over the summer. Okay, they'll come back.
This one has, this one's a little bit more challenging because it's got,
Next thing,
okay. Well, what would, the other day, what did we do when we had a number and a variable on it? We separated. So let's do that. -2, and then I'm gonna put parentheses and I'm gonna separate these. How can we break down root 20? Root 4 times root 5.
is there a highest perfect square that goes into X? No, because perfect square exponents are X squared, X to the 4th, X to the 6th. There's not enough here, is there?
So I can't simplify this.
So I just leave it.
-2 times, what does this break down to? This will break down. Root 9 times root 5. And once again, there's no highest perfect square that goes into root x. Well, root 4 is 2 times root 5 times root x -2 times 3 times root 5 times root x.
If I multiply two square roots together, can I just put them under 1?
So what's this the same as? Root? Don't overthink. Yeah, 5x. Minus, well, what's 2 times 3? 6. And these two together become root 5x.
Notice I got like terms.
Which means I can combine them. What do I get? -4. And remember, we don't change what's under the square root, root 5x.
So a little bit more of a challenging one. Still do it the same. Okay.